This question involves maximizing the profit that we could earn when there's a constrained resource. So this company constructs three different products, cleverly named VY, QX, and AM. And the first thing they want us to do is to rank the products in order of their profitability from most profitable to least profitable. Best way to start out with that I know, let's just duplicate some of the information we have about these products. So the price per unit here is $78.65. I'm just grabbing that from up here. This sells for $421.59, and this one sells for $145.92. Your variable cost per unit here is $62.40, $331.20, and $113.28. Just ticking those off right there. Now you have to calculate the contribution margin per unit, which you can figure out here is $16.25. This is going to be $90.39. We're just subtracting here. $32.64. So initially, you might be tempted to stop here and say, well, this is clearly the best product because look at that $90 compared to $33 or $16. However, remember, there's a constrained resource. And this machine can apparently only operate for a certain number of minutes. The machine is the constraint. So let's put in here the number of minutes, the time. So 1.3, 6.9, 2.4. So even though this particular product has the highest unit contribution margin, it also consumes the most of this constrained resource. It's a very needy product. So let's divide. Maybe I'll show it this way. So we're dividing right here. So 16.25 divided by 1.3 means that the contribution is $12.50 per minute. Down here, $90.39 per unit, but 6.9 minutes per unit means that our contribution is $13.10 per minute. And in fact, why don't I put some labels here just so that there's no confusion. And finally, $32.64 divided by 2.4 means that's $13.60 per minute. Now we have a little bit of a different picture, right? So we can look at this and we can say, well, suddenly product AM looks the most attractive. QX comes in second place, and the bronze medal goes to VY. And this is why. Let me put that up here a little bit. Is that because we cannot obtain all of the minutes on that machine that we would like, we need to look at how many dollars of contribution we can generate with 1 minute of time on that machine for each of these products. And this product here will give us $13.60 of contribution if we process for 1 minute on that machine versus $13.10 versus $12.50 here. So based upon demand, we should emphasize this production, then this one, then this one, which kind of is where B, so we've taken care of A. B is getting at this. And it's basically saying, assume that we have enough time on the machine to satisfy demand for all but the least profitable product. So that means we are able to make all of these and all of these. But some of these we will be unable to make. So if there were a way for us to purchase an additional machine, rent a machine, or somehow obtain some more machining time, what is the most we would be willing to pay? And that's going to be $12.50 per minute. And even at that price, we would be trading dollars or breaking even because we would pay $12.50 per minute, and then presumably we would make some more of product VY, and we would earn $12.50 per minute. So that's really the upper limit of what we would be willing to pay. ideally something south of that number would actually give us a little bit of profit.